Hello students. Welcome back to your physics class. This is our second lesson. So, let us see what we shall learn today. Before we begin, let us revisit our last lesson. In our last lesson, we discussed 1. The concept of physics. 2. The branches of physics. 3. Scientific method. 4. Career opportunities in physics. And finally, the importance of physics in our daily lives. Do you all still remember? Okay. Now, let us take a look at the lesson objectives. By the end of this lesson, you will be able to 1. Understand the physical quantities and their types. 2. Define fundamental and derived quantities and their units with examples. 3. Distinguish between fundamental and derived quantities. 4. Distinguish between fundamental and derived units. Are you ready? Let's dive in. In physics, we study the physical quantities. So, what is a physical quantity? A physical quantity is a number or set of numbers used for quantitative description of the physical properties of a phenomenon, a body or substance, and can be quantified by measurements. These numbers come with a unit that defines them uniquely. Therefore, to every physical quantity, we attribute a unit that defines it. For example, we have 30 meters. In this case, 30 is the quantity and meters is the unit that defines it. This way, it makes more sense. Now, let us talk about the types of physical quantities we have. First, fundamental quantities. They are the basic quantities that cannot be broken down and they do not depend on other quantities. Now, you should also note that the basic units that are used to define these quantities are called fundamental units. They are standard, and also they do not depend on other units. We have 7 fundamental quantities and units, as defined and approved by the international system. Let's explore them. Here, we have the 7 fundamental quantities, their units and symbols. First, we have the length. Length can also be described as distance, breadth, width, height, etc. The unit of length is meter, and the symbol is small letter m. We also have other units like kilometers, etc. 2. We have mass. We have the unit of mass as kilogram and the symbol as kg. 3. We have time. The unit of time is seconds and the symbol is s. 4. We have electric current, the unit is ampere, and the symbol is capital letter A. 5. We have temperature. The unit of temperature is Kelvin and the symbol is K. 6. We have the amount of substance. It is measured in moles, and it has the symbol mol. The last but not the least, we have luminous intensity. The unit is candela, and the symbol is cal. Now, these quantities and units serve as a foundational rock for other quantities and units. Now, let us look at another type of physical quantity known as the derived quantities. Let us explore the derived quantities and their units. Firstly, derived quantities are physical quantities that are obtained by combining 2 or more fundamental quantities. These combinations often involve mathematical operations like multiplication and division. For example, speed is a derived quantity because it combines length or distance and time. So, we can see that the fundamental quantities are the building blocks for derived quantities. Now, derived units are obtained by combining 2 or more fundamental units. In other words, they depend on fundamental units. Now, let us look at some key derived quantities, their derivations and units. Are you ready? Okay. Firstly, area. The formula for area is length times breadth. Now, the unit of area, meter squared, is derived by multiplying the unit of length by the unit of breadth. Therefore, the unit is meter squared. That is, the unit of length meter, multiplied by the unit of breadth meter. Let's proceed. Next is force. Force is a derived quantity. The formula is mass times acceleration. Now the unit of force, Newton, is derived by multiplying the unit of mass by the unit of acceleration. Therefore, the unit is kilogram per second squared or Newton. That is, the unit of mass, kilogram, multiplied by the unit of acceleration, meter per second squared. Next is work. Work is a derived quantity. The formula for finding work done is force times distance. Therefore, the unit of work is Newton per meter or joules. We arrived at this by multiplying the unit of distance by the unit of force. Next is volume. The formula for finding volume is length times breadth times height. Therefore, the unit of volume is cubic meters. This is obtained by multiplying the unit of length meter into 3 places. Next is pressure. The formula for finding pressure is force divided by area. Therefore, the unit of pressure is Newton per meter squared or power. We arrived at this by dividing the unit of force Newton by the unit of area meter squared. There are so many other derived quantities and units, you will get to know them as we go further. Well done, students. You are doing amazingly well. Next, we will talk about the major differences between fundamental and derived quantities. Now, here are some of the major differences between fundamental and derived quantities. First, definition. Fundamental quantities are basic physical quantities that cannot be expressed in terms of other quantities. This means they are natural, original, etc. Derived quantities, on the other hand, are physical quantities that can be expressed in terms of fundamental quantities. Moving on. They also differ in terms of units. Fundamental quantities have unique and independent units, such as meters for length and kilograms for mass. Derived quantities, however, have units that are combinations of fundamental units, example meters per second for speed. Next is measurement. Fundamental quantities can be measured directly using appropriate instruments, such as meter rule for length and clock for time. Derived quantities, however, are often calculated using mathematical relationships like multiplication between fundamental quantities. Next is independence. Fundamental quantities are independent of each other. This means they can stand on their own. Now, derived quantities, on the other hand, are dependent on fundamental quantities for existence. Again, fundamental quantities are limited to 7 in the international system, whereas derived quantities are unlimited. Finally, their expression. Fundamental quantities are expressed using a single unit, whereas derived quantities are expressed using a combination of units, often prefixes such as kilo or milli. Note this. The differences between fundamental and derived quantities are also applicable to that of fundamental and derived units. Ensure you pause briefly to copy down and do the assignments. Assignments will help you master what you have been taught. We have come to the end of this lesson. Before we go, let us summarize what we discussed earlier. Remember, we discussed the physical quantities and their types. We also discussed the fundamental and derived quantities. We explained the core differences between fundamental and derived quantities, as well as the differences between fundamental and derived units. Alright, student. Endeavor to listen to the lesson as many times as possible, and also ask questions for clarity. In our next class, we will discuss measurements and tools for measuring the fundamental quantities. See you in our next class. Thank you.